Earth's crust. Explained Geology 101 for undergrads. Welcome everyone. Today, we're diving deep into the Earth's crust. Think of the crust as Earth's outermost shell, the thin layer where we live and thrive. It's like the skin on an apple covering the entire planet. But there's much more to it than meets the eye. First, let's talk about its composition. The Earth's crust is primarily made up of two types: continental crust and oceanic crust. Continental crust is thick, around 30 to 50 kilometers, and composed mainly of granite. Oceanic crust, on the other hand, is thinner, about 5 to 10 kilometers, and consists mostly of basalt. These two types are quite different in terms of their composition and characteristics. The continental crust is less dense, but thicker, while the oceanic crust is denser and thinner. This density difference plays a crucial role in the movement of tectonic plates. Speaking of tectonic plates, the crust is broken into several large and small pieces called tectonic plates. These plates float on the semi-fluid asthenosphere below them. Their movement is responsible for many geological activities like earthquakes, volcanic eruptions, and mountain building. Now let's dive a little deeper into the layers of the crust. The upper part of the crust is called the lithosphere, which includes the crust and the uppermost part of the mantle. It's rigid and brittle, and it breaks during earthquakes. Below the lithosphere, there's the asthenosphere, which is more ductile and can flow slowly. This flow allows the tectonic plates above to move around. One fascinating aspect of the Earth's crust is its age. The continental crust is much older than the oceanic crust. Some parts of the continental crust are over 4 billion years old. In contrast, the oceanic crust is relatively young, usually less than 200 million years old. This difference in age is due to the process of plate tectonics. New oceanic crust is constantly being formed at mid-ocean ridges, where tectonic plates are pulling apart. As magma rises from the mantle, it cools and solidifies to form new crust. Meanwhile, old oceanic crust is being recycled back into the mantle at subduction zones, where one plate is forced under another. This continuous cycle of creation and destruction keeps the oceanic crust relatively young. The continental crust, however, doesn't get recycled as efficiently. Instead, it's built up over time through processes like volcanic activity and the collision of tectonic plates. This results in a much older and more complex structure. Understanding the Earth's crust is crucial for many reasons. It helps us locate valuable resources like minerals and fossil fuels. It also provides insights into natural hazards like earthquakes and volcanic eruptions, helping us to mitigate their impacts. So next time you look at a rock or a mountain, remember that you're seeing just a tiny part of Earth's incredible crust. It's a dynamic and ever-changing layer that plays a vital role in our planet's geology. Thanks for tuning in, and keep exploring the wonders of our Earth. Catch you in the next lesson.